Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Bismillahirrahmanirrahim. Welcome back. Problem 7.3. The statement of problem is given as this is state of element under the stresses. So you have to find the normal stresses on oblique plane or shaded portion of this part. So I have drawn this shaded portion over here. So you can see the angle is 45. So rest angle will be 15. Now the stresses are 10 kSI. This is 6 kSI clear, and this shear stress is 4 kSI. So these are the stresses. So if A is the area of this oblique plane or plane clear, so this area is let A. So this area will be angle is 15. So this area will be equal to A cos of 15. And similarly, this face of this area of this face will be A sine of 15. Now we will convert these stresses into forces. So again, this 10 kSI force is acting on this area. So this force, vertical force, will be equal to 10 into A cos of 15. Similarly, this horizontal normal stress is 6 kSI multiplied by this area, which is A into sine of 15, will give you A in 6 into A sine of 15. This is normal force. This is shear stress, that is 4 kSI multiplied by this shearing area, which is A sine of 15, will give you 4 into A sine of 15. And similarly, this shear stress, which is 4 in multiplied by over this area, will give you the shear force. So these are all the forces on this shaded element. So we will now resolve them into component. Clear? Now the normal force that is acting on this will be equal to sigma dash into A, clear, and the shear force that is acting will be in this direction, and that will be equal to tau dash and A into area. So we will find tau dash and sigma dash, normal stress on oblique plane and the shear stress on oblique plane. So let's start. We will resolve the components one by one. So first we will take the horizontal normal force that is acting this, and the value of this force is 6A into sine of 15 degree. Now you can see if we resolve them, let me draw the normal, the stress that we are going to, this is normal force that is acting on, and this is the shear force on oblique plane. Clear? Now we will resolve this force into two components. One along this normal force, and the second one is along this force must be taken parallel to this. Okay, so try to draw it parallel. And the second force is along this shear force. Clear? Okay, so now this as this force is perpendicular to this, and this force is perpendicular to this. Clear? This force is perpendicular to this, and this angle is 15 degree. Okay, so this force is perpendicular to this, and this force is perpendicular to this. So this angle is 75. So this will be 75 degree, and the remaining this angle will be 15 degree. Now this component will be equal to 6A sine of 15, I will not write degree, into cos of 15. Clear? So, and this stress will be equal to, this force will be equal to 6A sine of 15 into sine of 15. Clear? So this force has been resolved. Now we will choose another color. We will take another stress, that is 10 into this force. Clear? So this force is 10 into A cos of 15. I will also write over here 10 into A cos of 15. We will convert them into their component. One component that is in this direction, in sigma dash direction, and the other component is in, let me draw it by hand. Second component is in this direction. Now the value of, as this force is perpendicular to this and this force is perpendicular to this, clear? So the angle between them is 15 degree, clear? So this component will be equal to 10 into A cos of 15 into cos of 15, and this component will be equal to 10 into A cos of 15 into sine of 15. So be careful while doing this thing, clear? Now this second force has been also resolved. We will take this shear force that is acting in this direction. So I will draw it over here so that they do not mess up, clear? So this stress is equal to 4A sine of 15. You can see over here. Now we will divide them into two components, clear? One is in the direction of shear force, clear, and the second one is in this direction. And you can see this is the force, and you can see this force is perpendicular to this face, clear, and this force is perpendicular to this face, clear? So angle between them, this is 75. So again, this force is perpendicular to this face and this force is, so this angle will be 45, sorry, this will be 75 because this is the angle, clear, and this will be 15 degree, I think so. Okay, now you can see this surface and this surface are making 15 degree angle. So this force is perpendicular to this surface and this force is perpendicular to this surface. So obviously this angle will be equal to 15 degree. So again this stress was 4A sine of 15 degree. So this will be equal to 4A sine of 15 into cos of 15, cos of 15, and this force will be 4A sine of 15 into sine of 15. Now we have only one force left, that is we have done with this force as well, so we will convert this force now. So let me choose another color marker. I will choose yellow, oh sorry, yellow color marker, not this. Okay, so you can see this was the force, that is 4A cos of 15. I think it's not visible, so we will choose another one, green color. So we will convert them also into two components, one along this direction and second one in this direction. So this component, the angle between this angle will be 15 degree. This angle will be 15 degree. So you can check how this is your assignment. So this component will be equal to 4 into 4A cos of 15 into cos of 15, and this component this will be 4a into cos of 15 into sine of 15 degree. Let me check it. Sorry. If this is the angle theta, so this will be equal to cos of 15 into sine of 15. This should be. Let me check it. Okay. Kindly make a correction. This angle is not 15. This is 75. So how this is 75? Let me explain this. You can see that this force, which is represented as 4a cos of 15, this is perpendicular to this surface. Clear? This surface. And this stress is perpendicular to this surface. So this surface and this surface makes an angle 75 degree. So again this force and this force will make 75 degree. So this will be your 15 degree. So this component will be equal to 4a cos of 15 into cos of 15, and this component will be equal to 4a cos of 15 into sine of 15. Now you can see all the forces has been resolved, so we will apply the equation. Which equation we will apply? Equation sum of all force along sigma dash direction must be equal to 0. Okay, so you can see the one force, that is sigma a into dash into a, which is acting in this direction, and this direction is taken as negative. Clear? The second force is minus this force. You can see this force is minus this force in x direction. This is minus 10 a cos square 15. So minus 10 a cos square 15. There, the second force is this. You can say this force. This is in plus direction, so that is plus 6a sine square 15. Again, this force minus 4a into sine of 15 minus 4a into sine of 15 into cos of 15. Clear? And this force, which is again plus 4 into a cos of 15 into sine of 15. The sum must be equal to 0. Let's check once again. This sigma is in negative direction. This stress is force is again in negative direction. Again, if you solve this is again in negative direction, and this is in this is in negative direction, and this is also in negative. So this is also negative. Clear? Okay, so when you have a common in all terms, so a if you divide a on both sides, so you will get sigma dash is equal to minus 10 into cos square 15 plus 6 sine square 15 minus 4a sine, not a, sorry, because a has been cancelled. 4 sine of 15 into cos of 15 minus 4 cos of 15 into sine of 15. again this sigma dash will become equal to minus 10 cos square 15 plus 6 sine square 15, and this minus 4 this will be minus 8 into a cos of 15 into sine of 15 degree. Clear? So when you solve this by using calculator, you will get the value of sigma dash is 10.93 ksi. Now we will solve this for tau dash into tau dash. Clear? So again I have to write it somewhere else so that you can easily understand from the diagram. So let's check. This is sum of all forces along tau dash must be equal to 0. So you can see only force is tau dash into a, that is acting in this direction, that is positive, taken as positive. Again you can see this force 4 into cos, you can see this force is in tau dash direction, which is plus. So 4, and this value is given over here, 4 into a cos square 15. Clear? Now this force, this force might, and this is in negative direction, so minus 10a cos theta cos 15 into sine 15, so minus 10a cos of 15 into sine of 15. Clear? And then we will have this stress, that is in negative direction, 6a minus 6a sine of 15 into cos of 15. This is cos. Clear? Cos of 15. And then we have this stress, which is in, sorry, this stress, this, which is in negative direction. So minus 4a into sine of 15 into sine of 15. Clear? Their sum must be equal to 0. So when you solve this, you will be having equation, you will get tau dash will be equal to minus 4 into cos square 15 minus sine square 15 plus 16 times sine of 15 into cos of 15. So tau dash will be equal to, when you solve it by calculator, it will be 0.536. 0.536 ksi. Clear? So this was all about the problem. So we got so we get tau dash on oblique plane is 0.536 ksi, and sigma a dash normal stress on oblique plane is 10.93 ksi. So this was all about problem 7.3. Remember, you be careful while solving this problem because there are too many forces and converting them into their component will also confuse you. So if you have a clear idea, it will be easy for you to solve. Thank you for watching my video.